So now, Pascal van Kooten is going to give us a talk about DeepCare Chatbot, generating answers to customers using a hybrid approach of their learning and natural language processing. Please give him a warm applause.
Computer vision? Yeah. Sorry. Okay. A lot of companies are experimenting with these new technologies, computer vision, machine learning. And yeah, personally, I really enjoy these kind of human-machine interaction, kind of new technologies. So I don't know who's familiar with the Gartner hype cycle. A lot of innovation managers are. It's how they decide what to try next. Things like augmented reality, virtual reality. And well, this is where you can find me, at the red arrows. I've experimented with a lot of things. I really like to do so. I also contribute to projects on GitHub, so feel free to check it out. Things like using Wi-Fi signals in your laptop to have your machine understand where it is. Like when you look at your webcam and move your eyes, that the mouse is also following it. That's not really going so well, but it's a fun experiment. I've used some machine intelligence for web crawling, and neural complete. It's like a neural network that learns to autocomplete neural network code. I will give a talk about it in 2 weeks in Moscow. And well, finally, another fun project that I'm doing in my spare time is DeepCare. And I should say it doesn't actually have to do anything with care, really, but it's more about web care. So that's a bit of a difference. So when people reply on a Twitter, then there are actually companies that are reaching out. So it's more about web care. So now first, like, what is a chatbot? I don't know how many people know it. It's this idea that, for example, in Facebook Messenger, if you want to book a flight, you could go to a website to book a flight. But it's also possible to write some like Skyscanner bot, or I say like I want to book a vacation, and it says, okay, where do you want to go? Or maybe you can say like a whole sentence and it will interpret it correctly. But So I mean, in the business it said like first web, then phone apps came along, and now it's all about going to be, people don't really want to install a lot of apps, so it's going to be a chatbot in Facebook Messenger, for example. Okay, this is another example. So I'm interested in like natural language and like trying to understand what people are saying in text. It's also what we're doing at Jibes is a lot with like analysis on textual data. But what you can actually see with most chatbots is that it's really like scripted, and like what people are actually saying is it doesn't really need a lot of like language analysis. like saying anywhere or London, that's more like a lookup. Yeah, so I like to complicate it a bit. So yeah, those kind of chatbots are more like they're taking the initiative. It's kind of like the menu that you have on when you are calling and then press 1, 2 to do something, right? So I wanted to do more something like reactive with DeepCare. Yeah, so for me it's like a fun experiment to see something like, what about reactive? Some people wrote some text and like, let's try to generate an answer for it. Okay, so I've collected data. For deep learning it's important to have a lot of data, and I thought, okay, where can I find some interesting data? So in the end I ended up with AT&T, the phone provider in the States, and so they have 1.3 million tweets on their account. So I thought it would be interesting to do something with that data. So I collected 100,000 examples through Twitter where someone was saying one thing like, I don't know, I want an iPhone, and then some employee of AT&T replied to it. After doing some analysis on it, I was trying to look for like a cluster to start at, like not to try to solve the whole thing, but to start with a cluster. And interesting cluster I found was apparently they're doing a lot of social selling. So people are writing on Twitter, I want a new iPhone, and then there's AT&T who's replying to that, like, okay, maybe you want to click on this link. So that's an interesting cluster. So what is the problem for companies is, well, AT&T receives 3,000 tweets every day, and so they need a lot of people to answer these tweets. Probably they have a lot of other channels as well. And so corporations are looking for automated solutions. But yeah, it's really a complicated problem, because someone might say something about an iPhone, but just want some information about an iPhone, and someone wants to complain about an iPhone, and someone says, like, can you cancel my iPhone contract? There's a lot of, it's a complicated task. But also, maybe sometimes a bot needs to detect when it shouldn't reply. For example, when there's someone is upset or something, maybe you don't want to have a bot answer to that. Well, I thought, okay, let's try to do something like a bit more innocent. So like do this social selling task instead of looking at these sensitive problems. So my goal was like, without business constraints, like let's just want to work on a fun problem. And let's see if we can make a bot that can reply. It's a kind of a spoiler already, but I tried first to do it with deep learning. And there were some downsides that I thought, okay, you know what, let's just try a little bit of NLP as well, so natural language processing. I kind of do a two-stage model. First, like natural language processing, and then deep learning. I'm not saying that it's really a good idea. I think that in the end you will try to do it all in one model, but it was just an experiment. Okay, so now let's try. I made a little app around it because for me that's fun to do as well. Try to see if I can get that up here. Okay, well, it's just for show that you can choose a username. So this is kind of just an interface. It's not real, so you can type and this bot will answer, but it's not anything is happening with my username, or nothing is being written to Twitter. But you could actually imagine that this could happen. So you can. So this kind of an answer, or another example maybe. Let's hope it works and not someone killed it, but looks to be the case. luckily, I have the slides with some examples. Anyway, what I still can show you here is, when I find a mouse, it's like, I just did some days ago, I just like, okay, I inserted a query like iPhone or something on Twitter, and then you get some recent tweets and how the bot would reply to it. So yeah, it's pretty fun to see what happens. Sometimes it goes wrong, sometimes it's quite nice. Like, I don't know. Yeah, so the interesting thing is that, so there are generated answers. If you change a comma, then the output will be completely different again. That's usually something that companies don't like, right? They want the predictability. They don't want that you change a comma, which you would think is doesn't have any meaning, but it still changes the output. I don't know what I'm looking for, but yeah. So let's go back to the presentation. Feel free to try it. Maybe afterwards I can put it back online. So here's some examples. So what's interesting is that you can see that the employee or the bot replied with like "send, I heard you," and so it's like quite fun and playful. It's of course based on the actual data. So something like it detects that there's mention of two devices, and so it says something about we have great deals on both. I don't think that's actually really what the bot knows, but yeah, it's just text, right? But and this here you can see the NLP kind of when you say I want to see a movie, then it doesn't start generating answers, right? Because that's a problem with a lot of deep learning tasks that you do. If you give really nonsense to it, you are going to get really a lot of nonsense, and that's something that companies will not accept. Yeah. So I was kind of working with NLP on like I want an iPhone, but when you say I want to sell an iPhone, then again you have to make sure that it's not interpreting as like, oh, you want to sell an iPhone? Here, we can give you an iPhone. So yeah, another fun one. I want a case for my iPhone 6. We have got you covered. Like, right? It's fun stuff. Okay, so yeah, I see problem with deep learning, and that's like when you say stop my Samsung contract, then if a bot says, okay, I stopped your iPhone contract, actually there's not that much error in there, right? It just got the phone wrong, but yeah, that could have a big consequence when it suddenly starts canceling the wrong contract. Okay, so now I wanted to talk a bit about what I implemented. There's no code. But yeah, so yeah, this is kind of, I used a lot of pre-processing because I think it will help the strength of your deep learning and your like any model. It helps when you do like pre-processing, but I think you should focus on like the things that can be used in other projects or like keep it generic so you can really reuse it. And well, also spend a lot of time on the domain specific. So in this case, understanding iPhone is in the text is really important if you are building something around that. So make sure that you can correctly recognize that. Otherwise, you get things like a model, things like iPhone 5, and in the answer there's like, there's an iPhone 6. Like there's no guarantee that there's no guarantee that what is in the question will be correct in the answer with deep learning. So, okay, so then we have first phase 1, kind of should the bots answer or not, and phase 2, generating a unique answer, and afterwards I do post-processing. So, like when you see in the answers you see my username, that's something like you work with the variable called username, right? And then at the moment that you're writing it, from Twitter, you get someone's name, so you could use that name to personally address someone. Okay, so if we take this example, it's actually not one of the training data, but you can imagine it is. it would be seen like this after the pre-processing. So, like the names, we know names, so I can, and we know usernames when you get through the Twitter API. So whenever you see these names, that's kind of pre-processing, or you see the Twitter handle, you can replace it with the token name, and then later kind of try to do that back. And it's interesting because I think that they're trying to take this kind of like using these contexts, these kind of tricky things. They're trying to build models for doing that in one model with neural network. But yeah, it's a challenging thing, and I thought, this is just fun to see how far can we get. We're just trying to hack something together. So you see other things like offer link, money amount, the initials, and webcare link. So, mentioned the name. There was often things like employee names and the availability of them. There's a lot of tags and a lot of links. And I experimented a bit with links because, they give, of course, a lot of links, but maybe you're interested in like an offer link, right? So maybe you just want to give a latest offer, and that should come from some other API. You want to give the latest offer. So you kind of want to normalize links, I think. At first I just did link. Later I changed it a bit to like goodbye link, or like this is our team and this is like an offer. Emoticons is nice to treat well, so you can use them as in your model. So then I did also some like specific or domain-specific pre-processing. Like you have to understand the brand name really well, or competitors maybe, and products. But the more time you have for your project, the more I think it will be benefiting you if you try to generalize a bit. Though, of course, there are a lot of purists, and especially in academics, that don't do any kind of pre-processing where there's tokens with question marks attached to a token. And, I just think it can help, right? You don't want to, or I don't want to have that in the back of my mind, that could be making your model worse. So I do the pre-processing to try to help to generalize, and I only want to pre-process things that I think, maybe I can reuse that, and the domain-specific things. In this case, only product, but you can imagine more. So then we come to the restricting the answering, like when can it answer or not, and I did that with NLP. So I don't know how many, there are some people that were interested in it. You have kind of the oldest way to do natural language processing is just taking words and just seeing them as a unique token, right? You have the word hello, that gets a 0. The next word I gets a 1. Something like that. Each individual word having a unique number. I thought, like, let's try to use something more complicated, because I don't think you can easily work with just that. Benefit of NLP is like it allows some generalization, because when you have like want or wants, then that's just simply different numbers, like how that's being featurized. So there's no generalization. But if you use a lemma, so then cats becomes cat, or like stemming of verbs, wants to want, then kind of you get some kind of generalization. So a bit of a problem is that you're depending on a language model getting that right. Also with part of speech. And so I show here an example of a dependency tree. It's using Spacy. And what you can see here is that the sentence "I want an iPhone" is being put in like a dependency tree. I guess it's better to read about it than me trying to explain it now for a long time. But you can kind of get you can get more out of language. So in this case, want is a verb and it's on the root level. You have I, which is the subject. You have iPhone, which is an object. And I use this kind of information for the restricting when you should answer or not. if you're doing a naive thing like this, so you're using these features and you're just saying, okay, we're going to use all these lemmatized features, part of speech features, dependency tree features, you end up with really, like, I mean, if you just use words, it's a lot, but it will explode. So yeah, I thought, well, maybe let's try some rules there. But yeah, creating rules can be time consuming. Benefit of using the NLP in this case is that it's very transparent. When you see something like when something slips by, the model makes a mistake, it shouldn't have answered, it's still very transparent to why it went wrong. Yeah, so the rules can actually give guarantees, deep learning can't. Okay, so I use Spacey. It's a very great library, in my opinion, for natural language processing. They're also including a lot of the nice thing. I think they also are going to include neural networks in there. Well, in my case, I build the rules using part of speech lemma and negation. And yeah, so it's a bit going to be technical and small. But yeah, so the simplification I made is you need the words want or need as a verb in your sentence. Like then only we're going to use this. You want to have the product, or iPhone, as a nearby child of this like root, so underneath in the tree. You don't want to have any like negation. So when you say, I don't want an iPhone, you don't want it to be wrongly interpreted. So I thought it's a fun way at least to do this not, because you don't often see it being used in a lot of models, right? Especially the simple models. They don't use any information really correctly with the word not. So if you say, I don't want to fly to Spain, then it says, great that you're flying to Spain, right? So it's actually a tricky thing, and I wanted to solve it using the negation in the part of speech. And another restriction I have is that the subject is I in this case. So you cannot, my sister wants an iPhone that doesn't work at this moment. But of course you can expand on these rules. So this is the case that we had. I want a case from my iPhone 6. And when we are making the dependency tree, you see that it looks like this. So you have the little check marks for these kind of parts of the rules that are working there. More examples. I don't know how readable this is, but yeah. So when you say I want a Samsung Galaxy, it shouldn't. Well, I mean that's the restriction I put myself, only selling iPhones. So then it shouldn't suggest something. When you say I do not want an iPhone, it also should not make a suggestion. And when you say I do not want an iPhone, but I want a Samsung Galaxy, then it's again not iPhone, so it shouldn't react. And the last one is like I do not want a Samsung Galaxy, but an iPhone. So, and the nice thing is that it still works. But yeah, so this is all rule-based, just for should it answer or not. And then we go to the generative part. So right. So now the model. So I applied all these rules also in preparation of training the generative model. So I had 100,000 tweets, and after using these kind of rules preparation, I was still left with 15,000 samples, which is not super big, but still quite nice because it's a much smaller domain than trying to solve, like, yeah. So, so the training of the models is also using this pre-processing step, which means that after you get some new input, you're first saying, is it okay or not according to the rules? Yes, it's okay. Okay, then we can generate an answer. Okay, so I used Google Sec to Sec. I don't know who knows it. It's about mapping sequences of words or numbers to another sequence of words or numbers. It's used in machine translation or text summarization, conversation modeling, image captioning, according to Google. And well, I think a lot of people are experimenting with it in even more ways. Yeah, one of the examples is the Chinese sentence to English sentence example. And the goal is, of course, given the training examples of a lot of Chinese and English sequences, which do not have to be the same length, to learn a good model. But yeah, so it can also be used to create a chatbot. It's not exactly like a machine translation, but yeah, you can say something like, given this question, this answer should be there, and then the model can work with that. Also fun to know is that they announced that they are probably using something like this in Google Translate. Okay, so this is their explanation of it. For me, it's not the best to explain it with this one, so I found this example, and I encourage you to read this link. So we have sequence of words, sequence of answers, and so first step is the words into numbers. Then you have an encoder, so it's sec-to-sec long short-term memory model. You're trying to learn from, like, when you see to give an example, I would like to eat, could be an example. Like, then on the top right, you have to learn these transitions from I would to would like to eat as a whole. In the end, you have some state which is fixed. Let's say 32 variables at the end, and so you're learning this based on these words. I'm sorry for this explanation, but but the thing is, so after you do this encoding stage, you end up with fixed size, and then so when you're doing the decoding, so you're trying to like in another language, or then it would go over it. So in another language, then I would like to eat. But it normally, if you have a Markov model, you have something like, okay, what is the chance that given I would, the word is like, and if that's the highest chance, then you could use that. But in the example of I would like to eat, maybe if that's the most occurring way, then it will not change to something else. But if in the encoding, so in your question, there's the word eat in another language, or right, or in clue of iPhone, then this information is available when you're trying to learn this decoding. So instead of I would like to eat, it can then do something that's less popular choice. I would like to drink, because it's available in this encoding stage. So it's about learning the encoding and the decoding. Yeah, I would encourage you to read the blog. I use TensorFlow for this, and more specifically if you want to see some code, then go to this repository. You can easily get started yourself with that. These are my network settings. I started with really small models, so the downside is that you can capture a lot less, and but I wanted to see if it kind of works with like smaller settings, and then slowly build it out. I think due to the time, it's not really interesting to discuss what these parameters exactly are, or quickly maybe, like the batch is, okay. This is something you can read easily online. You can here also see the tensor board, so that's where you can monitor the loss. It was training for 24 hours on my CPU. So if you have a GPU, that's probably 3 hours, and if you do it if you're much more serious about it, you can do much more larger models, and maybe you don't have to stick to first this smaller domain. Okay, so my conclusion is like, well, it still makes small grammar mistakes or things that you find odd, but in my opinion, it's quite fun, at least, to see what it comes up with. It still makes mistakes in logic, but I try to kind of minimize that by this approach. It's not optimal because it's two models, but it was for me a very fun experiment. And I don't know if you heard about this OpenAI model that was training on the movie ratings, and then they found that it understood sentiment. Well, this model also contains a bit of sentiment. That's a bit of a joke. That was my presentation.
Any question?
Question about like the hyperparameter you choose. There's the embedding. Why do you choose like 128? And what's the relation with the like embedding layer, for example?
So my hyperparameter search was very simple. I start with small and I double everything. Then I think like, okay, it's still okay. So yeah, I just increased everything. It's not really yeah, I didn't spend a lot of time on hyperparameters because I found that it worked quite well. So in the original repository, they're using 32, and I thought that it gave a little bit of view. Like I felt like I couldn't really represent a lot. So yeah, then for me it became logic. Okay, let's just higher the values of embedding. So yeah, it can contain more intricacies. Similarly with the amount of layers, well, amount of units, and I stick to 2 layers because well, that's kind of what a lot of people are using, right? And when I changed it to 3 for fun, like it took quite a bit longer to train it. So I thought, okay, let's just stick with 2. So there's no science from my side behind the choices. It's
More questions?
Thank you.